Hello everyone. In this session, we will deal with the wavelength, frequency, time period of a sound wave. In the last session, we have studied that sound is propagated through a medium through a series of compressions and rarefactions. So, we have drawn the figure of compressions and rarefactions. To take a review, once again, a recap is there. Compressions are regions where particle density is small. So you can see compressions over here, and rarefactions are regions where particle density or pressure is low. Okay children, so you have to understand about the width of compressions and rarefactions first. So I have marked that all the width of compressions, all compressions are having equal width, and all rarefactions are also having equal width. So same spacing is there for a compression and a rarefaction that I have marked here. So now we will go for the concept of wavelength. Wavelength. So what do you mean by wavelength? Wavelength is the distance between two consecutive compressions or two consecutive rarefactions. So let us take a point somewhere here in the middle of the compression. So this is another compression, the next compression. So the distance between two consecutive compressions is what is meant by wavelength. So in order to get a specific point, we are taking the middle of each compression. So when we mark from the middle of one compression to the middle of the next compression, we will get the wavelength. So what is wavelength? Wavelength is the distance between two consecutive compressions, or it can be termed as it's the distance between two consecutive rarefactions also. So what is wavelength, children? Wavelength is the distance between two consecutive compressions or two consecutive rarefactions. What is the unit of wavelength? We know that it is a length, right? So the unit of wavelength is meter. Next, we go on to the concept of frequency. Frequency of sound. If a sound is getting propagated as a series of compressions and rarefactions, what do you mean by the frequency of sound? So listen children, while we are standing here, okay, some compressions and rarefactions are crossing us, suppose. So number of compressions or number of rarefaction crossing a point per second is what is meant by the frequency of sound. So once again, it's the number of compressions or number of rarefactions crossing a particular point in the medium in 1 second. So that is number of compressions or number of rarefactions crossing a point per second in 1 second. Per second means in 1 second. That is meant by frequency of a sound wave. And the unit of frequency is hertz. In order to honor the great scientist Sir Heinrich Hertz, we use the unit of hertz. Then the next topic to you is the time period of a sound wave. What do you mean by time period? Time period is defined as the time taken by one compression and one rarefaction to cross a particular point. You have to note that one compression and one rarefaction constitute a single wave of sound. So, time period is defined as the time taken by one compression and one rarefaction to cross a particular point, and the unit of time period is second. I hope that you have understood it. So, taking a recap, all the compressions and rarefactions are of equal width, and wavelength is the distance between two consecutive compressions or two consecutive rarefactions. Frequency is the number of compressions or rarefactions crossing a point per second. And what is time period? Time period is the time taken by one compression and a rarefaction to cross a particular point. And even not the units also. Wavelength is having a unit meter, frequency is having a unit hertz, and time period is having a unit second. I hope you understood. Thank you.